Okay, let's unpack this. When you think about electric vehicles, maybe you wonder about the battery. Are they really safe?
Hmm.
Especially, in extreme situations, like a crash or maybe some kind of thermal event. It's always been a challenge, right?
Hmm.
Containing all that energy safely. So today, we're doing a deep dive into something pretty innovative. Xiaomi SU7's inverted battery cell technology.
Hmm.
We're pulling from some recent articles, some research to really understand this breakthrough. It's making some significant waves.
Absolutely. And our mission here really is to help you understand not just what this tech is, but why it's such a significant leap forward. For EV safety, yes, but also performance. We want you to get those aha moments, see how the pieces fit.
Great. So let's jump right in. The core of this is Xiaomi's CTB, cell-to-die architecture, and these inverted cells. How does inverted actually work, and why is it such a big deal, especially with CTB?
Right, CTB is key here. It means cell to body, integrating the battery right into the car's structure, saves space, adds stiffness. And the inverted part, it's actually ingeniously simple. Imagine a standard battery cell. Now just picture it flipped upside down in the pack. That's basically it. The cells, and importantly, their pressure release valves, are positioned upside down compared to how it's usually done.
Upside down. What's
Okay.
that?
Yeah, and what's really fascinating is that this seemingly small change, it has a massive impact. If there's an extreme event like a thermal runaway, which is what everyone worries about, any energy released is vented rapidly downward.
Downwards, away from the passengers.
Exactly, away from the passenger compartment towards the ground. It maximizes safety built right into the design.
That makes a ton of sense for safety. Okay,
Yeah.
but here's where it gets really interesting for me. Beyond just safety, what else does this clever design do, like for performance or efficiency?
Oh, it achieves quite a bit.
Hmm.
This design really pushes boundaries. Let's talk integration efficiency first, how much space the battery takes up. These CTB packs hit 77.8%. 77.8.
Wow. Yeah, it's among the highest in the world. That lets you have more cabin space or maybe a sleeker car design, and it boosts overall vehicle performance by about 24.4%. Plus, it shaves 17 millimeters off the battery height. Lower center of gravity, better handling. Okay, so better performance, more space.
Mm.
What about the big one? Range.
Mm.
And is it actually durable?
Good questions. Capacity can go up to 150 kilowatt hours. That gives a theoretical CLTC range over 1,200 kilometers. Now, CLTC, that's the China Light Duty Vehicle Test Cycle. It's just their standard for range testing.
1,200 kilometers, even theoretical, is huge. And the protection.
It's multi-layered, seriously robust. We're talking 14 layers of physical protection, 3 on top, 3 on the side, 8 on the bottom, plus aerogel insulating materials. These can resist temperatures up to 1,000 degrees Celsius.
1,000 degrees. Okay, that's like a fortress.
Pretty much. And thermal management is also top-notch, double-side cooling, with a massive 7.8 square meter heat dissipation area. That's like 4 times the industry average.
4 times.
Yeah. And overseeing it all is Xiaomi's own battery management system, the BMS. It meets the ACE-LAD safety standard. That's the highest level for automotive safety integrity. Think aircraft systems level. It's got 3 independent thermal runaway monitoring systems, gone through over 150 safety checks. It's comprehensive.
That level of engineering sounds incredibly thorough, really impressive. But does this exact spec apply to all the SU7 models? Or are there differences between the versions?
That's a really important distinction to make. So the Pro and Max versions, they use ternary batteries from CATL Contemporary Amperex technology. And yes, those feature the inverted cell technology for that downward pressure release we talked about.
Okay, Pro and Max have it. What about the standard version?
The standard version uses BYD's Blade battery. It's a different design. It manages pressure too, but laterally, meaning it vents energy outwards to the sides of the battery pack, still safely away from passengers, mind you. But it doesn't use the inverted cell tech.
Ah, I see. So different engineering approaches.
Exactly. 2 different paths, but both aiming for and achieving equivalent high levels of safety for you, the driver.
Right. So connecting this to the bigger picture then, how does an innovation like this, even with the variations, position the Xiaomi SU7 in this super competitive EV market?
Well, it clearly puts the Xiaomi SU7 right up there with the most advanced EVs, particularly on safety and energy density. It's not just about, selling another car. It signals a real push for the whole industry. It offers better passenger protection and really challenges the existing standards. It shows how manufacturers are constantly innovating. And maybe a final thought here. This kind of advancement isn't just about one car, is it? It's really about pushing the entire EV industry to rethink how we get to that ultimate goal, maximum safety and efficiency. Makes you wonder, what does this mean for how every EV might be designed in the future?
That's a great point to ponder. And thank you for joining us on this deep dive into the Xiaomi SU7's battery breakthrough. If you found this information valuable, and we hope you did, please do give us a like and subscribe to the channel. It helps us keep bringing you insights like these.
Yeah, definitely. And we'd love to hear your thoughts, too. Leave us a comment below. Tell us what stood out most to you from today's discussion.